Our new unit is about rational functions. Rational functions are simply functions that have fractions. If you think about it, a ratio can be a fraction, right? So a rational function is a function that has a fraction where the variables are in the fraction. And so we're going to be doing multiplying and dividing rationals today, and then adding and subtracting rational expressions on Wednesday. And then the last two lessons before we test will be on solving. And we'll need to know how to multiply and add in order to solve rational equations. Okay? And so that's what we're doing basically between now and spring break. So that should help you plan a little bit. Okay. So we're going to do a short warm-up to review some things about like exponents and factoring. So just take a minute and try problems 1 and 2, see what you can remember. And if you're not 100% sure, that's why we use a pencil. You can erase it if you make a mistake. All right, here we go. First one, we multiplied, right? And I saw a lot of you got 12, and then the end part was tricky, right? Does that show up? This is n to the 1, and when we multiply, what do we do with the exponents? Add them, good. So you got 12n to the 4 over 10. And then there's one more step, right? We can simplify? All right, divide them by what? Yeah. So when we divide the numerator and denominator by 2, we get 6n to the 4 over 5. What questions do you guys have? Okay. All right, in number 2, this type of factoring is a little simpler than some of the other ones that we've done because it has a 1 as your a value. So this is just 1x squared. Remember that if this was 2x squared, we would have a slightly longer procedure, and we will see one of those today too. All right, so we're looking for numbers that multiply to -50 and add to -5. Did you find them? What are they? -10 and +5. Good. So x minus 10 times x plus 5. Yep. Questions? All right. So the reason why we needed to review factoring is because factoring is going to show up in a lot of our multiplication problems. And the nice thing is that when you factor, some things can cancel out. I want to just remind you about inverse operations really quickly. If I had x plus 5 over x minus 2, I cannot cancel these x's out because what I have here is a division and addition. Division and addition are not inverses of each other. So this is already simplified. But if I had 5 times x and -2 times x, then my x's could cancel out and I would get -5/2. Because this is multiplication and division, those are inverses of each other, so they can undo each other. Okay? We'll be using that idea later on, but it's a really important thing to remember when we're simplifying rational expressions because people are always trying to cancel things out like these x's, and it's not going to work for you if there's a plus or a minus here. Okay? Okay. So, for example, here, because of this minus, I can't just cancel out these x's, but what I can do is I can factor the 6 out as a common factor. And do you see another expression that will factor? Yeah, the 9. So I can take the 9 out of this. Now, when I multiply across, I'm going to be multiplying the 2x squared times the 6 to get 12 x squared, and I still have the x minus 1 on the top. And then I'm going to multiply the x times the 9 to get 9x. And I have an x minus 1. Okay? Yeah, I'm not done, but I do want to hear questions. I'm multiplying the 12 times the x squared times the x minus 1. The x minus 1 is like a unit stuck together, okay? 12 times the x squared times the x minus 1. On the bottom, I've got the 9 times the x minus 1. So my x minus 1s can cancel because they are being multiplied by the other factors in the numerator and denominator. And now I'm left with 12x squared over 9x. That can simplify further, right? Yeah. Yes. Why didn't I simplify that? Because you're just ahead of me. I haven't gotten to it yet. Okay, so 12 over 9, I can divide 12 and 9 by what number? 3, good. So 4 over 3. What's x squared divided by x to the 1? What do you do with those exponents? You subtract them, right? So I'm going to get x to the... Just normal x, good. And will it end up on the top or the bottom of the fraction? The top, because I have more x's on the top. So I had 2 x's on the top and 1 x on the bottom, and when I cancel, I'm left with an x on the top. Okay, I'm going to give you a minute to process that, because I know that that is a big thing there. Let's look at the next one. I see the 7n on the top and the bottom. I haven't technically put it into one fraction yet, but I am going to put it into one fraction. And I can see that they're going to cancel because the 7n is being multiplied by the 9n minus 24 and by the 24n to the 5 minus 74n squared. So I can cancel them right now. Just make my life easier. Because it's a multiplying problem, and so when there's a multiplying problem, you can cancel. Now I have to see what I can factor. What could I factor out of 9n minus 24? 3? Yeah, I think you're right. 3 times 3n minus 8. All right, in the denominator, what's the greatest common factor of 24 and 64? I heard an 8. Who was that? Good job. All right, so I'm going to take out 8. Can I take out some n's? N to the what? What could I take out? N to the 2. Thanks, Sally. So I'm looking at this right here. Okay. Oh, you mean the numerator here? Sorry. I was looking at this one. And then I factored out the 3. Yeah, so now I'm looking at the denominator, and we're factoring out 8n squared, and so then you're just thinking to yourself, 8n squared times what would be 24n to the 3rd? So 8 times what is 24? Mm-hmm. And n squared times what gives me n to the 3? N, good. Minus 8n squared times what would give me negative 64n squared? 8, yeah. Look how pretty that is. I love when things cancel out. It's like life becomes so much more neat.
To get the you just factor the 9n minus 24.
Yes. Yeah, good. All right, so I'm going to cancel out the 3n minus 8, and I think I'm done. Morning. Okay, so you should be able to see that you can factor out a common factor in the numerator and in this denominator. And then look at this denominator here. So trinomial like in your warm-up. Take a moment and see if you can factor these numerators and denominators. Okay, the first numerator, I can factor out what number? 10, good. And then x plus 3. I'm going to put parentheses on it just to keep it together, okay? Then down here with the 5, I can factor out the 5. And then I have x plus 3 also. I'm just going to put parentheses on this one so I don't lose track of it. And then here I've got x squared minus 6x plus 8. Raise your hand if you can factor that for us. Go ahead, Gideon.
Oh yeah, -4 and -2.
Okay, what did you actually write though? Perfect. I mean, it doesn't have to be in parentheses, so yeah, I get what you're saying. You want to put this one in parentheses too? Yeah. So the 5 doesn't technically have to be, but these parentheses are just kind of reminding us that each one is its own factor. So some of these will cancel. Well, one will cancel easily, right? 2 of them will. The x minus 4 and the x minus 4. The x plus 3 and the x plus 3. What else? The 5 and the 10, good. So the 10 divided by 5 will give us what? 2. All right, I'm going to actually write that step out because I think some people are having trouble with all the work that we're doing in one step. All right, so then we're going to say 10 divided by 5 gives us 2, and it's over x minus 2. Why can I not cancel these 2's out? So if you have no numerator, you can always put a 1 there. So it could be 1 if they canceled. But why don't they cancel? Oh, sorry. I wanted to hear you, Sally. I'm sorry. Because it's not being multiplied, right? So remember that the fraction bar means division. And we're looking for things that are being multiplied together because those can cancel. But now I just have a subtraction in between here. So I cannot cancel division and subtraction. Okay? I know it's tricky. All right, try number 4. Number 4 is kind of like your warm-up problem. So try number 4. Look, guys. If you multiply these, you're going to get 36 over 144, and then you have to simplify that fraction, right? It would be a little bit simpler just to cancel out the 9's right here, wouldn't it? You can, because, see, there everything's being multiplied, so I can just do that. So now let me do 4x to the 3. I have the worst eyesight. Y to the 5 over 16 x squared y. All right. Anything simplify? Tell me one thing that simplifies.
16.
Yeah, so 4 over 16 is equal to what fraction? 1/4. Very good. Okay. X to the 3 over x squared equals what? X is right. All right, who said y to the 4? All right, so Gideon, how do we get y to the 4? What did you subtract? 5 minus 1. So remember, even though you don't see a 1 there, that is y to the 1, and that's how they get y to the 4. And we're done.
Can we just put x on x4?
Yeah, and Blaine reminds us that that 1 is not necessary. You could, 1xy to the 4 is the same as xy to the 4. So it's okay if you didn't put the 1. All right, let's go to the other side. All right. We're still moving on. when you divide two fractions, you just have to add in this one more step where you take your second fraction and you do its reciprocal and you multiply. You see, so first fraction stays the same, second fraction, it's the reciprocal and you multiply. So it's just one more step. So trying that with numbers, you've got 3/7 and then multiply and then 12/5.
Wait, can you explain it one more time?
Yeah, so this is a procedure it's really from elementary school, but it's one that a lot of people forget once they start to use calculators. So you have 3/7, and instead of dividing it by 5/12, you're multiplying it by 12/5. I can show you a different example to make it a little bit more clear about why that works. So think about 3, the number 3, divided by 1/2. Okay? So, say we have like 3 pizzas, right? And every person wants to eat half a pizza. So how many half pizzas do we have? How many half pizzas do we have if we have 3 pizzas? 6, right? We have 6 half pizzas. So 3 divided by 1/2 is 6. You can see it if you draw a picture of the pizzas, right? 3 divided by halves equals 6. So another way to think of that problem is to flip this, and you get 3 times 2/1, or just times 2, equals 6. Okay? So dividing by a fraction is same as multiplying by its reciprocal. So we have to add that step in here. It's just one more step to add in. It actually doesn't make it any harder, just longer. All right, x squared minus 4. This is the difference of squares. We have not practiced difference of squares yet today. Does anybody remember the pattern for difference of squares? Okay, one sec. All right, I don't know why this problem's all the way over here. I'm gonna work over here. So it's x minus 2 times x plus 2 is my pattern for difference of squares. And then I've got over 20 y to the 4th. I'm gonna change my divide to a times. And then I'm gonna put this on the top, 16y squared. And then what factors out of 3x plus 6?
3x plus 2.
Yeah. Okay. So going from here to here, I factored. I just brought this one down. I changed divide to multiply, and I flipped my fraction. Does anything cancel yet?
Yeah,
X plus 2, good. It's going to cancel. So let me bring down what I have. 16y squared, y minus 2, or x minus 2. Is that right? Are they y and x's? Oh my goodness. Good morning. 20 y to the, oh wait, I should multiply the 20 times the 3. So that would be 60. Thank you. All right, 16 and 60, what's the greatest common factor? I don't think 6 is a factor of 16. 2 is a factor, but I think there's a bigger one. 4. Yeah, 4. So let's divide 16 and 60 by 4. All right, y squared divided by y to the 4. We're going to subtract the exponents. And what do we get?
2.
We get y to the 2. Does it end up on the top or the bottom?
Bottom.
Yeah, it's on the bottom because we have more y's on the bottom. So when we cancel, the extras end up on the bottom. And then I still have an x minus 2 that hasn't gone anywhere. Okay. So what we need to do real quick is review how to factor a trinomial when the a value is not 1? Please pay close attention because it's been a long while since we've done that. Okay, first step, you multiply the a value times the c value, which is basically the number in front of the x squared times the number that doesn't have an x. And so that gives me 6. So I'm looking for numbers that multiply to 6. And then they're going to add to your b number, so add to -5. Okay? Take a minute and find those numbers, multiply to 6 and add to -5. All right, so the numbers are -3 and -2. Does it matter which one you put first? It doesn't matter. Please focus. I'm going to bring the 2x squared down. Here's where the -3 and -2 come. I'm going to split this one into 2 pieces. It's going to be -3x and -2x. Okay. So, after you find the numbers that multiply to 6 and add to -5, we use those numbers to break up our middle term. It doesn't matter which one you write first. Your problem will look a little bit different in the middle, but you'll end up with the same answer in the end. Okay, so I brought down 2x squared. I brought down plus 3. Instead of -5x, I wrote -3x minus 2x. And I got those numbers because those are the numbers that multiply to 6 and add to -5. All right, so what we end up doing is we group the first two and we group the last two. I'm going to put a little plus here and then group the last two. Now, those are not factors because I put a little plus here to remind myself this is not a multiplication. I'm just adding these two groups together. But what I do is I factor a common factor out of each group. So in the first group, what do they have in common? X. Yeah, they both have x, so I'm going to take out the x. And I've got 2x minus 3 when I take that out. Plus. The next group doesn't seem to have anything in common. So you can always take out a 1, and in this case, I might want to take out a -1 because then I'm going to end up with the same thing over here. You want these two parentheses to match. So right now, if I took out a +1, it would not match, but if I took out a -1, it would. Okay. So I took out a -1 so that this parentheses would match this one. Now when they match, that's one of your factors, 2x minus 3. And the other factor is x plus -1 or x minus 1. Okay, I know it's been a while since we factored like that, and it was a little bit rocky the first time we factored. But this process will work for you every time. All right, so I'm going to bring this 2x minus 3 times x minus 1 over 2x squared. Now I'm dividing, and it's not a fraction, so I'm going to make it a fraction by putting it over 1. And now I'm going to flip it and multiply. I can probably factor that. What could I factor out of that? (2x squared minus 3x). What can I factor out? 1 what? 1x, yeah. So I'm going to take out 1x, and I'm left with 2x minus 3. And that's good news, right? Because that means I can cancel something out. So 1 times x minus 1 is just x minus 1. And then I have 2x squared times x to the 1. That's going to give me 2x to the what? 2x to the... So it's 2x to the 3. If I had it if I was writing it not in the denominator, it would be to the negative 3. I think you're thinking of the negative 3 because it's in the denominator. Yeah, if I was writing it without a denominator, it would be 2x to the, or it would actually be 1/2 x to the negative 3. But because it's in the denominator, it can stay x to the 3. Tricky, right? All right, let me give you a minute to process that one. We'll do one more, and then we have a challenge problem. All right, let's see if I can catch up to you all. So 5x was on the top. On the bottom, I saw you factor out the 3. Change your divide to multiply. And then remember that we're flipping the second fraction. So the factors of x squared minus 6x plus 8 go on the top. All right, so negative 2 times negative 4 gives you positive 8 and adds to negative 6. And then this one we can factor out x. All right, and so then luckily we had x minus 2 and x minus 4 cancel. And we ended up with 5x divided by 3x. And what's our final answer? Yeah. Very good. 5/3. All right. It's time to try the challenge. All right, I am ready to go over this. Quiet down, please. All right, this one in the middle is not a fraction, so I can put it over 1 just to remind me where the 3x minus 5 is. When I put these two together, when I put the first two together, I'm actually not going to multiply them because then I would be trying to factor them out again, and like that's just making extra work for myself. So I'm not going to distribute it yet, just in case something cancels out. And then the divided changes to multiply, and I flip my fraction. And then I've got to factor this difference of squares. We talked about that. 3x minus 5 times 3x plus 5. Okay, so I just put these two together first, and then I changed my divide to multiply, and I flipped this and factored. And now I do have some things that cancel. This one and this one. This one and this one. And so I'm left with x over 3x plus 5.